What's up, math scholars and math haters? This is Mr. W. This is the last video in a four-part series on interpreting and using normal distributions. And today we're going to learn about a calculator command that will let us calculate the percent of data between any two boundaries on a normal distribution defined by a mean and a standard deviation. It is called normalcdf. It stands for cumulative distribution function. If you know calculus, it basically just takes an integral. But I have the actual commands. In order to get to this command, we need to find the second button, and then we need to find the button that says vars, which above it in the same color as the second button will say distribution. So if you press these two buttons in succession, you should wind up here. The one we need is this one, normalcdf. Do not do normalpdf. Do not. It will not give you the right answer, and I guarantee if you're doing a test question where it asks you to find CDF, one of the trick answers will be, what would you get if you found PDF? Anyway, we press enter and it appears on our main screen, and it's at this point that I want to go over what exactly we need to type in. There's a very specific order that these need to go in. So if you're one of my students, I highly recommend, if you're going to focus on anything to take notes on from this board, focus on this section. So here's what we need to type in order to make the calculator do what we want to with the normalcdf command. It's going to be 4 numbers separated by 3 commas. And when I say commas, these aren't there just for show. You actually need to type this comma key in between each number or else the calculator will not do what you want it to. So the 4 numbers with commas separating them are, first off, the lower bound, the smaller of the 2 data numbers that you're going to need for the problem. Next, you need the upper bound, the larger of the 2 numbers. So you're basically telling the calculator, go from this number to this number. The next 2 numbers are when you actually tell the calculator the particular distribution that you need. And this is defined by your mean and your standard deviation. And I have those in corresponding colors up here. I just didn't have enough room to write everything. So you need lower bound, comma, upper bound, comma, mean, comma, standard deviation, close the parentheses, and then press enter. So let's actually give that a try. Once again, I have the IQ scores, and we were supposed to try to find the percent of people with an IQ between these. You can only see 2, but there's actually 4 problems here. So I have normalcdf pulled up. I need 100, comma, 115, comma. The mean was 100, and the standard deviation was 15. Now, if you remember from the second video, we should be getting about 34%. And it is just about 34%. It's not exact. The empirical rule isn't exact. It does a lot of rounding and estimating, but this is about 34%. And I'm going to write it to 3 decimal places. 0.341. I'll write it as the calculator gave it to me for this particular video. But if you remember how to go from decimal to percent, you just take this decimal point, move it over 2 places, and this would be 34.1%. All right, so now let's work with 73 and 83. These are not numbers that show up here, but that's one advantage of normalcdf. You can type in any 2 numbers and it will still work. So, second distribution, normalcdf, 73, comma, 83, comma, 100, comma, 15. And that gives us about 9.3%. So I would write that as 0.093. And again, looking up here at our numbers, 73 and 83 are about here, so this would take up some of that 13.5%. So this is a number that we expected, that we're okay with, based on what we already know about the normal distribution. So now, we need to deal with IQ of 70 and 130. Second distribution, normalcdf, 70, comma, 130, comma, 100, comma, 15. Just like with z-scores, our mean and standard deviation are going to be the same for every normalcdf we do with this distribution. This one gives me 0.954. Now this, of course, is a little more than the 95% we were expecting from what we knew about the empirical rule. But just remember, the empirical rule rounds and estimates a little bit, so that is 0.954. And finally, we'll look for the percentage of people with IQs between 120 and 150. So let me pull this up. Second distribution, normalcdf, 120, comma, 150, comma, 100, comma, 15. And it's going to read this number as 150, even though it had to separate the digits. So that is, again, or that's another one that gave us about 9%, so that's 0.091. Which, if we think about it, even though it's a big range of numbers, 120 to 150, and this was a smaller range of numbers, 73 and 83 were a lot closer to the center of this distribution than 120 and 150. So even though we had a bigger range, we were really getting into the tail end of things here, and that's why a bigger range produced an almost equivalent probability or percent. Now, again, I have pizza deliveries. We'll do a few examples with these. For instance, finding the percent of deliveries that took between 10 and 30 minutes. Now, at this point, I do need to remember 10, 30, that my mean and standard deviation have changed. So I need to type in 25 and 8. Make sure I have commas on everything. And it gives me about 70.4% or 0.704. I'll do 5 and 15 minutes next because I want to save these for last. So for 5 and 15 minutes, normal CDF, 5, 15, what was it again? 25 and 8. This is why you always put commas in. You need commas. All right, so let me try that again. Normal CDF, 5, 15, 25, 8. That gets me about 10%, in fact, almost exactly 10%. So this would tell us that 10% of these pizza deliveries take between 5 and 15 minutes. And this gives me almost 10%, but not quite, because if I round to 3 decimal places, it would just be 0.099. So now, these two are a bit of a trickier type of problem. If I see more than 20 minutes, there's no upper bound that it gives me, so I need to make up my own. Pretty much anything past 49 will do. Because the percentage of data on either of these tails is so small, we can pick a bound that is a little above 49 or something like that and be okay. Just to be safe, though, I like to just go with some power of 10. So in this case, I'll do normal CDF from 20 to 100, just to make sure. Now, of course, there's no way we're going to get every single little thing, every single little possibility, but at this point, for a distribution with 3 standard deviations up at 49 and I'm typing in 100, it's going to pretty much cover just about everything. Make sure I add my comma, 25, 8, and this gives me about 73.4% or 0.734. And finally, the percent of deliveries that are less than 45 minutes. Now, I picked this example because a lot of places will keep track of their delivery times and say, hey, if it comes in after 45 minutes, your pizza's free. So this would actually help us figure out what percentage of their orders they would actually get paid for. So I'm going to find normal CDF again. And this time, since it's a less than, I need to just go ahead and pick something that's a good bit to the left of 1. So this time I'll go with negative 100. So negative 100 up to 45 with a mean of 25 and a standard deviation of 8. I'm making sure to put my commas in. And this gives me what I expected. 45 is way up here. So we're expecting that the vast majority of their deliveries would get delivered in less than 45 minutes. And in this case, it's about 99.4%. All right, so that is how to find or how to use the normal CDF program in the calculator. If you're my student, best of luck on your assignment. If not, I hope that this was helpful for you.